Okay, welcome back everyone. Thank you for joining for our second session of the day. So we will be hearing from Danfoss EDITRON from Antti Väyrynen. I hope I am saying that correctly. I apologise if I'm not. Very broad Englishman here, so not very good with accents. But yeah, so Antti will actually be speaking on electric driveline solutions for off-highway vehicles and machines from Danfoss. So Antti has been in mobile electrification and energy systems business since 1997 in the research and development area, also in product management and the sales environments. He's also worked in various management positions in Finland, Austria, and Switzerland before joining Danfoss in 2018. He holds a master's degree and a licentiate, sorry, my accent's really bad, degree in engineering physics from Aalto University of Tech, Finland. So I will pass you over now to Antti, who will be doing his presentation on electric driveline solutions. So to speak, I pass the spotlight over to you, Antti, and please take it away.
Thank you, Liam, and good morning, everybody. So I hope you can see my screen already, so I can start my presentation. Okay, so today the topic is about electric drivelines, and to start with, I tell a few words about Danfoss. I will go this through very quickly because we have still a lot of interesting material to cover. So Danfoss Group facts: we are almost 28,000 people and roughly 6.3 billion euros. These numbers will be increased by roughly 40% because during this year, 2021, we are about to acquire a company called Eaton Hydraulics. So that will make us much larger in the field of hydraulics. We are a privately held company and with headquarters in Denmark. So this is how the Danfoss Group is built. So we have three segments, and those are Power Solutions, Climate Solutions, and Danfoss Drives. The one in the middle used to be heating and cooling still some months ago, and the one on the left is where we sit. So we are part of Power Solutions. The reason why we are there is that our products are focused on and intended for off-highway machines, and they're really made for harsh environment. And the market expect that some of the hydraulics business will be cannibalized by electrification, and that is why we are here as part of Danfoss. Looking at the Power Solutions product offering in more detail, you can see that we have four core business divisions. Those are hydrostatics, controls, and work functions. And then we are the fourth one called EDITRON. We are the only one having a name that is not described the product as it is, but we are focused on electrification, while the others are for hydraulics and various control equipment and control functions. And then the fifth one is Hydrogear, that is a separate brand making equipment for lawn mowers. But today we talk about EDITRON, and that's why we're here. So these images here illustrate briefly what EDITRON does. So I will not go in detail in all the projects, but I can at this point show some of these and tell a few details. So the history of the company EDITRON goes back in year 2009 when the Finnish company VZ was founded. And since then we have made a lot of projects on sea, on land, and on highway. And today we have three business lines. One is marine, one is off-highway, and one is on-highway. I'm responsible for the off-highway business, and here we can see a few examples of what my team has done. So you can see here some pushback tractor from airports, some drilling machines, some forest harvesters, and so on. We have started recently a number of big OEM projects. Many of those are unfortunately not public, but I can tell you that the working machine segment, and especially construction machines, they are getting electric pretty fast because there are a lot of various regulations for emissions, especially in the city areas. Okay, the first thing I want to start you with about EDITRON is the products. I will not go in detail with the product because this presentation time would not be enough for that. But just to give you the overview, what we have in the portfolio is electric converters. That is, in practice, the product range needed to rotate the machines. So we have inverters, we have DC-DC converters to connect energy storages to the system. We have diode bridges and active front ends and filters for the grid connection. Then we have a quite wide range of electric machines, starting from, let's say, less than 50 kilowatts, ranging up to 4 or even 6 megawatts. All of the machines we are making are either permanent magnet or so-called SRPM technology that have very high efficiency. Then we also have driveline subsystems comprising electric machine, inverter, and in some cases a gearbox. Those subsystems are primarily made for on-highway and bus and truck applications. So, as said, these products are designed for harsh environment so that these can be used in any off-highway applications, even if there is a lot of vibration and shocks and dirt. And this portfolio is enough to electrify basically any machine. Besides these hardware products, we have also quite nice software portfolio. Most of the software is running inside the inverter, but besides this, we have also so-called application softwares that are combining these products, and I will explain those in the next sections. So the next slides are about electric wheel loader project. To be able to develop our own products and also get some experience on the custom applications, we started a demonstrator project for electric wheel loader in our application development center in Denmark about 2 years ago. So we purchased a commercial 13-ton wheel loader, and we disassembled that successfully and made that fully electric. That was quite a tough project because the OEM was not involved in the project. So for us, this was a showcase to implement our own portfolio, and also it's being used now as a platform to develop electro-hydraulic solutions. We are working on so-called eSolutions software package. And what is also important to know is that the conversion was done completely by in-house engineering teams. So it was our system development team from the ADC, as well as my own sales team who made this conversion. And now from this on, we are using this for development and also for customer project. This is the architecture in brief, how the machine was made. So it's powered by a battery that has a voltage of roughly 800 volts, 145 kilowatt hours, and that is then connected to a DC bus that is powering the traction and then also the hydraulic work functions. And also, of course, we need an onboard 24-volt battery, and that's why there is also a DC-DC converter. And it's grid connected, and all what you see here besides the battery and the gearbox is made by Danfoss. These photos illustrate a bit the work we did. So we installed their gearbox, coupling, transfer case, and 2 machines, one for the traction and one for the hydraulic work functions. And the toughest part here was the battery, because the space available for the battery was not, of course, designed for the battery. It was designed for the diesel engine that we took out. So after some trial and error, we got this running last year, and now we are really focusing on the application development. But we did not redesign only the driveline. We also replaced most of the displays, joysticks, control functions, because we wanted to make this completely made by Danfoss. So in practice, on this wheel loader, you can find more or less all the products that we could have available for such a machine. And if you and your customers are interested, this is possible to see, because this is, in a way, it's a public project, because it's not owned by any customer. This table summarizes in brief the key parameters. So it used to be a big diesel engine, 7.1 liter displacement. Now it's a 800 volt, 140 kilowatt hour battery. And just picking a few details here, we expect the loader cycle time and also the capacity to be increased a bit. So therefore, we have not done all the measurement yet because some of the work function development is still ongoing. But we expect that this wheel loader in electric version will do the job better, more silently, without emissions, of course, compared with the original one. Okay, I mentioned about software. So making this kind of wheel loader work requires a lot of software. It's not only the software inside the inverter that is operating the machines, but we also need something for the work functions and also for the propel. So when we started making the wheel loader, what we had is, of course, the hardware, the inverters, the machines, and so on. But to make it run, we also need a battery and also a BMS embedded. This is, of course, not enough. We also need chargers. In this case, the charging was made by our own equipment, but there are, of course, various options how the charging can be made. It could be also an off-board DC charger. But as you see in the middle, there is one block missing. There is some space left. So what we need here is functional application software. So what we started in parallel with this wheel loader demonstrator project is that we started working on a software package called eSolutions. And that's something that we are launching today. So we call this EDITRON eSolutions software package. It has three major blocks. One is called eTraction, and this eTraction is what you need to make the wheel loader move. Besides this, we need software package for the work functions, because as we change in this case many of the hydraulic components to electric, we need to also rework the work functions. And that's, of course, the case as well for the OEMs who are planning to redesign their machines to electric or make a completely new design. And this eSolution software package is something that is available to customers for pilot use already this year and for larger volume sales next year. And the third element in this software package is called energy management. So you know that the battery is very different from the fuel tank, and therefore the energy management of the battery and then how the energy is distributed between various loads needs also some logic and intelligence. So these are the three elements inside the eSolutions software that we are about to launch now. Then a few words about the eTraction software. So the eTraction software is something that is already in use now in our wheel loader in Aalborg, Denmark. And a few key topics here is that it needs to be functional. So that is really designed to really optimally drive the propel function in the wheel loader, to make it as efficient enough and also safe. Safety is very important. Of course, safety is important for any machines, but when we create new functions with electric machines, of course, the control needs to be redesigned. And here we need to consider various safety standards, and this has been really in key focus here. With Danfoss, we have very high standards for functional safety and a dedicated team at the ADC in Denmark working on this functional safety. So this project actually is not really done by EDITRON. EDITRON here is the electrification partner and in practice the customer, but the development has been done by the global R&D teams with the main expertise in this case in Denmark. And our intention is to make this software package pre-developed so that any customer can install it in their own machine with some customization. And the key thing here, of course, is time to market, because we want We want you to be quick on the market and win the business. And what is also important to understand is that we have so-called +1 software platform that has been made to combine the hydraulic and control components, and now we are also including the EDITRON electric components in this software platform. And of course, this eSolutions software package will be +1 compatible. So here's the timeline in brief. As I already mentioned, it's already running at the wheel loader that we made ourselves. We have some pilot projects planned for later this year, and the official sales release will be next year. However, if we have some key customers who are willing to start piloting this already this year, this can be discussed. Okay, then one slide about eWork function software. As you see on the animation on the right, the wheel loader needs to do something besides moving, so it has the bucket, and therefore we need some work function software also available. So this is already being developed, not released to any pilot customers yet, but that will be the case later this year. So besides the functionality, as I mentioned, functional safety has been really a key focus, and we have more than 18 safety features implemented in the software, and it's aligned with various harmonized safety standards. Okay, then the last part of my presentation today is about how to get the products available, and how you can see what kind of products we have, and how to design systems. Of course, our sales team has the skills and the competence to support you in your projects. We have a global sales team, and then we have a team of system engineers who are really experts on the products. But to make the system design easier for you, we have installed and launched last year on our website that is called electrificationstory.com. We have launched so-called e-calculator and e-configurator tools. These are available for traction use and also for marine use. Today I will show you some screenshots about the traction use configurator and also about the e-calculator. So these are both available on the website, and the link is on the last page of my slides. So on that page, if you want to make a design for your vehicle, in this case it has been a bus, you need to enter some key parameters like the tire size, elevation, maximum speed, weight, and so on. And then you can make this kind of driving performance graph. So with this calculator, you can make the dimensioning which kind of products you would need for your application. And as an outcome of this calculation, the calculator proposes components that could be used. This is not yet connected to our shop that you could buy this, but that's also part of the plan at a later point, that this would be part of the web shop. So in practice, this is for you to make the preliminary design, and then you can contact us for more details. To be able to do the full calculation, then you need to register on the website, but then we can also contact you more easily. So that was the e-calculator. The next part is so-called e-configurator. And this e-configurator is to illustrate what kind of components are placed in the machine and what the driveline looks like. It also will tell you the performance and the energy savings. This is a screenshot of the e-configurator. So here on the left-hand side, you can see that we have selected here a wheel loader, and this is battery-driven, so it's not a hybrid. And then based on the weight and the machine type, the configurator proposes the components. That in this case, it proposes a machine of 500 Newton meter torque and related converter. And then on the right hand side, you can see how much the fuel consumption is improved versus the standard diesel-driven one, and how the productivity is improved. Of course, this depends on many parameters, but this is calculated based on our standard setup. Okay, so this was my introduction to EDITRON and Danfoss Power Solutions offering in brief. To summarize what we do, we provide electrification solutions, and this is, of course, one of the mega trends that is linked to climate change. And as said on this slide, there are as many as 30 million cars equipped with Danfoss technology, and that actually means the Danfoss silicon power equipment. And we as EDITRON, we are a global leader in hybrid and electric marine vessels. We have our own marine team who is working on projects. And the product portfolio that we have in use for all these application segments is basically the same. Okay, so this was my story today in brief. On this page, you can find my email address, link to Danfoss EDITRON homepage where you can find more product data, and then also a link to electrificationstory.com website, where you can find those nice calculators and configurator tools.
Perfect. Thank you very much for that, Antti. I think that was a very good presentation into Danfoss as a company, but also to their electrification solutions with power lines. So we did get a lot of questions. We got over 10 questions to go through now, which
Wow.
yeah, a good turnout, let's say. Of course, we do have quite a lot of time left, so I think we will be able to get through the majority at least. So we will start with obviously the most voted one, which is from Michael Bunting, who asks, do you use a 4-wheel motor system or is it a 2/3 motor system?
Well, it always depends on the application. To get the best performance for proper use in a difficult terrain, of course, if you have a 4-wheel motor use, you get the best performance, but of course it's always a cost issue. So in this wheel loader, we didn't go for motor use because of mechanical reasons.
Right, thank you very much. And please let us know if there is any follow-up to that, Michael. So the next question is from Andre Almeida, who asks, how do you select for a given voltage level in construction machines? Is it due to regulation? If yes, which? It's not so clear to us what regulations apply to wheel loaders or excavators. If you want, I can break that down a little bit more.
Yeah, thanks. That's a very good question. Actually, it's one detail I did not mention in my presentation. At the moment, the products we have in the Danfoss EDITRON offering are for high voltage. And high voltage meaning that it's above the automotive safety limit, that is in practice 60 volts. In most systems, the battery voltage with us is between 600 and 800 volts, and the nominal voltage of the machines that we are working on is either 500 or 690 volts. And are there some regulations? Well, yes, there are regulations. So people and equipment needed to do service and maintenance for the machines is of course different if it's let's say 48 or 500 volts, and therefore many OEMs would like to keep the voltage low, but it's not possible, and it makes little sense to keep the voltage at 48 volts if you're handling powers that is more than let's say 50 kilowatts, because then your cables would be very thick.
Great, thank you very much. And thank you, Andre, as well for your question. So Chad Larish, he asks, were there any changes to the work circuit to improve the overall efficiency?
I guess this is related to the wheel loader. Yes, as said in the presentation, we have also downsized the pumps. So in practice, we have replaced more or less all the components besides the cylinders, because we don't have those in our portfolio.
Okay, thank you very much. And please let me know if there is any follow-up to that, Chad. Also, what different kind of machines do you have in eCalculator to support non-road mobile machinery area? Is the tool free of charge?
At the moment, we do have a limited set of options available. Actually, I need to check what is the latest status today, but we have buses, and basically that eCalculator is not yet available to make the dimensioning for the work function. So therefore, it's basically for the propel or traction application, and in that use, it makes little difference if the application is a bus or a wheel loader.
Okay. Okay, thank you very much. So we have had a few more upvotes. So from Andrea Hick, he asked, do you also see a market for low voltage small machines in regards of full functional safety and availability of suitable components? High voltage has its challenges, for example.
Yes, we do have market. We do see market for low voltage equipment as well. At the moment, we Danfoss don't have this in our portfolio, at least not yet. And I know that many OEMs are starting the electrification of their portfolio, starting with low power machines, and we are looking at that area carefully as well.
Fantastic. Okay. Yep. So Tatiana Mina from Tampere University, what is the voltage level for your electric wheel loader?
The battery voltage is 800 volts.
800 volts. Thank you.
Yeah.
Thank you.
We see a trend also in electric vehicles that the battery voltage is going up. Many of the vehicles you still see on the road are roughly 400 volts, but there are OEMs already releasing models with 800 volts.
Fantastic. Thank you very much. So from Andreas Henicki, do you foresee the subsystems to remain at low voltage or move to high voltage?
Let's say the subsystems inside the cabinet will most likely stay with low voltage because of safety reasons, but most of the other functions will go to higher voltages. Of course, you can run a fan still with even with 24 or 48 volts, but there will be a trend to let's say in practice to downsize the DC-DC converter between the two voltage levels, and therefore I expect that many of the subsystems will go also high voltage.
Okay. Okay. Jeroen Sweatmel asks, what technology did you use for cabin climatization? Actually, this is a question I'm not able to answer. In this wheeler, I expect that is original, but I need to consult the team. Of course. Okay. Yeah, and so Gerten Roix asks, when do you think this will be introduced to the market? I think they may be talking about the eCalculator. The eCalculator and the eConfigurator have been online since last year already, and so these are available. But I'm not sure if that was the question. If they talk about the wheel loader, as a product like this, it will not be available on the market because we are not the machine OEM. However, all the components, including the eSolutions software, will be available, and most of those are already available to the market. Great. And Gerten, please let me know if that answered your question or if you meant a different area of Antti's presentation. So we have another one from Jeroen Sweatmel from Wabasto. He asks, a service network for machines is crucial. Since this machine is packed with Danfoss technology, is that something you plan to do yourself or with the traditional OEMs and their dealers? Well, the electrification components are just a part of the portfolio, and for the sales, we are using the same sales organization. So my team is actually not a sales team. We are supporting the global sales team, and the same applies to service partners that we ideally go through the same network, same distributors, and so on. Of course, some of the service teams may be missing the electrification components, so we may need to propose some new solutions here. But when it comes to OEMs, especially large OEMs, we expect them to have their own service teams. Fantastic, thank you. Okay, and I believe there is just one other question from Harmut Rigat. He asks, what was the biggest challenge in converting the wheel loader to electric?
I would say the biggest single challenge was the battery. We had, of course, challenges fitting in the powertrain, because that was not designed to be electric. So we had to introduce a gearbox and a transfer case. That still, battery was the biggest challenge.
Okay, thank you. And I think that is a really good note to actually close the speech on that. Obviously, knowing what the challenge was for yourselves there, I think is a really good overview, really, of electrification, and of course the problems with not with batteries, but obviously implementing the battery tech into electrification, having it able to work properly. But no, thank you everyone for the questions there. I think that was a very engaging session. Also a big thank you to yourself, Antti, as well, for joining us for the presentation, also preparing that presentation, and of course for Danfoss EDITRON as a total as well, for supporting us as one of our sponsors for this event. So a big thank you to you, Antti, and I believe you will be sporadically around anyway, and if anyone has any questions.
Yeah, I will be. You can connect me through the platform or in my email, as you can see on the screen.
Perfect. No, that's great. That, and of course, Danfoss EDITRON, they do have their own sponsor stand, and of course there will be people answering questions there as well. So if you do have any questions specific to Antti, please do message him or email him, or please do visit the sponsors tab and Danfoss EDITRON. But other than that, a big thank you again, Antti, and thank you for your presentation. Cheers, thank you. So we have kept quite well timed today, so we are only 3 minutes into our coffee and networking break. So as mentioned yesterday, there will be some virtual meetings happening from now till the end of break, and also through lunch and the last break of the day. So please do go visit the community tab, the meetups and virtual meetups, or the discussion topics below. And please do network, please do engage with everyone. Of course, we learn by doing mostly. We are, as a race of people, mostly kinetic learners. So please do go visit, ask as many questions, and do the networking. And of course, do visit our sponsors and the sponsor stand. So we will be returning at 10:35 with the next session, which will be from Mikko Pilatti, who is from VTT Research in Finland, and will be speaking on the roadmap of electrification and hybridization of NRMM, a case studied view of it. So we will see you in 20 minutes for that next session, and I look forward to seeing you there. Bye.